So let's take a look at rotations. And that's mostly what we're going here for, this idea of rotations. Rotations isn't always easy because so many things are happening at once, and they're happening in ways that we're not necessarily used to. This idea of rotate, kind of to spin around, has a lot to do with a center point and a circle. It's like you start here and then you go over here. And how do you measure that rotation? Well, let's kind of think about a few things. So first, you got kind of like your full turn like this, and that would be a 360-degree type turn. Well, what if you just did kind of a half turn? Well, that would be 180. And then what if we did just a quarter turn? Well, then that would be 90 degrees. So we got these full turns, half turns, quarter turns, and we're trying to see what's happening with these pieces. Well, so here we go. Now it's not easy to see because this half turn kind of looks like what's happening here, almost like a rainbow from one side to the other. But it's not a full rainbow. It's not even a half turn there. It's actually just a quarter turn because you go from one quadrant to the next. So if we were to label each of these quadrants, we got 1, 2, 3, and 4. We go from 2 into 1. And when you just go in, you just change one number quadrant, that's just a quarter turn. So that's our first thing. First, it's a quarter turn. It's a quarter turn. And it's not only a quarter turn, it's, how can we see it from here? It's a 90-degree clockwise. Now, clockwise meaning that we're going from here over to there. Quarter turn. How do I know where I start and finish? Well, a lot of it has to do with that prime thing. So here's my original A. A prime means it's the copy that it goes to. All right, now let's look. That'll work for us. So I'm going to pick blue to highlight this point there to this point there, because that's the same point on each one. I can see that. We'll call this like P, and this will be P prime. And so let's see what P to P prime, how that changes, how we go from one to the next. Well, P is at -1, 3. So that's at -1, 3. And that's going to go from, so we got -1, 3. Turns into, over here we're at 3, 1. Alright, that's kind of interesting. It's like the numbers are similar. Not exactly the same because like we got some change in negatives, switching back and forth. Let's try another number just to clarify work. Now I'm going to pick this point up at the top. I'll call that Q. So then I'll have over here Q prime. Alright, now for Q to Q prime, what's happening there? Well, first Q, that's at -2 and 5. So we start at -2, 5. And we're changing to this point over here, which that's 2 more than 3. So that's at 5, and that's up to 2. So then we go to 5, 2. And you might be able to kind of see what's happening. I notice two things. One, whoops. Oh, we just lost it all. I'll rewrite a lot of it here. So we had Q going to Q prime, and that was -2, 5 to 5, 2. And then we had the others. That was P to P prime. So here was the P and P prime ones, and that was -1, 3 to 3, 1. And what's going on with these? Well, there we go. The idea is when you do this rotate, so if you imagine kind of a circle, and this circle is doing this rotate, it's making a 90-degree turn here. Similarly, this point turning to this point is going to have that same kind of 90-degree turn. It's making that 90-degree turn to get from one point to the next. This was our Q prime, this was our Q. So it's going from one thing to the next. So how do we say that? How are the key features of shape in figure A alike or different from figure A prime? Well, first of all, it's congruent. What do we mean by that? Well, it's got the same size and shape, so same size and shape are the same. That stays consistent. But what does switch? Well, it looks like X and Y swap. Okay, so that kind of makes sense. And some of the sign changes too. It looks like the x becomes y, but one of those is negative. And then the y goes to x. Now let's put these like primes. There we go. So the original x turns into like a negative y prime, or vice versa. You could have said negative x equals positive y prime, but one of those needs to be negative. The original y becomes x prime. But what's happening there? X and y swap, and now both are positive. Both are positive. That's the general idea. Okay, so that's pretty much what's happening there. And we said it's a 90-degree clockwise turn. Let's see what's happening in the next one. We can go a little bit faster for this one. Actually, for these two, we can do both of them. There we go. All right, so we got a prime to a double prime. Let's use a blue color here. We got this one going to this one. Let's just look at those numbers. So that's going to become, that was at 3, 1 for, and this was like our p prime, and now we're going to p double prime, is going to, this is 1, negative 3. So we did the same kind of thing. We switched the x and y, and the second number, the y here, changed sign. Let's look at the other one for some. And I put it on that q prime and q double prime. So there's q prime, and here would be q double prime. That's going from 5, 2 over to 2, negative 5. Excellent. So we're having that same kind of when it comes to those things changing. Now, if I were to kind of draw a line from this to the last piece, oh, you know what? Let's do that with a straight line. Here we go. So if I'm drawing from here, then to here, then we got a rotation happening with this Q. And the same thing with the blue one, not that they had to line up on the same thing, but they both had a 90-degree turn here in the corner. So again, we got that. So it's a quarter turn. Another way of saying that is 90-degree clockwise. There we go. How are the key features? Okay, so again, we are congruent. That's the same. And again, we swap x and y. Excellent. So lots of stuff happening there. This time, you know, x and y were both positive, and now the y became negative. The y double prime became negative, and the x was still positive. That's kind of interesting there. All right, let's go to this last one. So when I'm looking at the turn is different. Instead of just changing one box, instead of going from like quadrant 1 down here to 4, or quadrant 1 over to 2, or 2 to 1, I'm like skipping a box. I'm going from 4, skipping, and going back to 2. So it's going all the way across diagonal to the other side. So that's a little bit different. And in fact, that's a bigger turn. That's like a half turn. Because if I were to count from 4 and go around, I'd go like 1, 2, 3, 4. But right now, it's going 1, 2. It's like 2 quarter turns. Or we could say a half turn. And here's where some ambiguity comes in. Because we know it's 180 degrees, but which way did I go? Did I go back one and then back again? Or did I go forward more and forward again more? So is it a clockwise or counterclockwise? Because a 180-degree turn, it's neither clockwise nor counterclockwise, and it doesn't really matter. You know, it's not one way or the other. So direction, not important. So direction, not important, because it's the same both ways, not important. It's the same for both. Now I want to look at these numbers because these numbers are definitely different. So I got red. If I were to pick that this was P double prime, is now going to P triple prime. Let's see what those are. Well, that's changing from, let's see, let's pull it up here. That was at 1, -3 going to -1, 3. Ooh, that's interesting. All right, now for green, we'll do the Q double prime up to the Q triple prime. 1, 2, 3. So to go from Q double prime to Q triple prime, we were at 2, -5. And then that changes to, well, now we're at 2, -2, +5. So this is way different. Y are kind of more the same, but one time it's negative, then the other time it's positive, and one time it's positive, and then the other time it's negative. So what do you call that? How do you call that when that symbol out front changes? That's the sign, actually. So we could say the sign changes for X and Y, for both. Excellent. All right, how are the key features of shapes to figure A prime, A double prime, A triple prime, all alike or different from each other? Okay, so the coordinates, we use the same numbers over and over and over again. You use the same numbers, but it's sometimes positive, sometimes positive, sometimes negative. All right, and also this should be kind of there for you, but I'm not sure if you're catching it. But it's always congruent. You know, we always got the same size, same shape. So always congruent, which was the same size and same shape. There you go. All right, so that's kind of the basics of the classwork. Let's look at this last part, this front page, and then for the back side, it's going to be more your stuff that you're going through. So let's see what we've got down here for this bottom part. Describe the relationship between A and A triple prime. Well, you kind of get this idea that it's the same. They're the same. But why? Well, the transformations, the rotations add up to either 0 or 360. What do we mean by that? Well, let's look at the steps that we did. First, we did a quarter turn, another quarter turn, and then a half turn. So we either got 90 plus 90 plus 180, which would equal 360. That's one full revolution, bringing you back to the start. Or we had 90 plus 90, and if we went in the opposite direction, then we would have said that's minus 180. That's why we said it doesn't matter kind of which direction you go, because that would be 0. So whether we did one full turn or no turns, we still start at the same place. We go back to the start. So this is back to the start. Excellent. So that's the big idea with this classwork. Hopefully you guys got that. Again, go back, watch the video a second time if you need to.